Give a hand to Niklas.
Hello. Good morning.
Can I start early or?
Thanks for having me here. I'm Niklas. I'm working for Eurecat, the local research and development center of Catalonia. And my job is making audio software, nowadays still in C++. And I'm fairly new to Rust, but very well relate to Claudia Saxer's talk yesterday. My journey was pretty similar in the first few months. And today I'm going to talk about web audio and how Rust can be used for that, but also a little bit why Rust might be a good option for audio software in general. So why would you want to put complex web audio or complex audio applications on the web in the first place? I'm part of a community that does music with code. I don't know, who does not know live coding here? Oh, everybody knows it, I'm surprised. Doing visuals on stage with small programming languages, with domain-specific languages. And one of the problems that this community has is that workshops often end up being installation workshops, and after 2 or 3 hours, people barely manage to install their things, which is kind of sad because the stuff is fairly easy to use and it's a lot of fun to use and it might be educational. A lot of people might get interested into programming, but if you need 2 days just to install, I don't know, Lisp, Pascal, whatever kind of weird environment people develop their languages on, that might discourage a lot of people. So if you can put stuff on the web, you don't have any installation efforts, it's pretty platform independent, you just need to load a website, you don't need a lot of computer literacy, and it may just lower the boundary for people to use your stuff and might make it more fun for more people. So I went on the journey to try to port my own stuff to the web, and I'm still fairly early in that process, but I was looking for the perfect web audio stack. So what are the requirements for audio software in general? You need a deterministic way of working for the audio thread itself. That means you shouldn't allocate memory in the audio thread. You shouldn't lock, you shouldn't wait on condition variables and all those kind of things. And audio software is inherently multi-threaded because you always have the audio, the real-time thread, and some control thread at least to either set parameters or schedule stuff, sequencing stuff, and so on and so on. And out of personal preference, what would be nice to have, not only for the web, but for audio software in general, memory safety is a big thing, because if once in your life you had the experience that you missed an array boundary and suddenly get random memory contents pumped directly into your ear, what at work we affectionately call noise from hell, then memory safety becomes very important suddenly, just to be able to keep on working and not being deaf. Portability is a thing, because like for me, like if at some point I would not be happy with the web performance anymore and want to have a native program, it would be nice if it would be easy to port. Small footprint, I don't like bloaty software. And the easier it is to use, the better. So what were my options here? I could go with pure JavaScript, but it's, well, it's not that portable. I'm not an expert in JavaScript, but I think compiling it to a native executable is something different. It's a dynamic scripting language. That means it has probably something like garbage collection, which in some languages can easily stop the audio for a second. You get glitches, and it gets easily bloaty. I don't want to chime into JavaScript bashing here. I like JavaScript, but I don't think it's the best for this kind of purpose. You could just compile C++ with mscripten, but that's neither very convenient nor very, I don't know, comfortable. I don't know. But so I came across Rust and WebAssembly, and that seemed to be a fairly good option. Why? Well, so first of all, I looked around and tried to find something that has already been done, and I came across this little synthesizer that's not made by me, but by some person from Japan. And that was the proof of concept that showed me, okay, it's actually working. You can. It's like a little TB303 simulation, kind of funny. Even though it was still lacking a couple of things like sample playback or precise timing and all kinds of things that still needed to be done. And apart from that, everything that's written about it is in Japanese, which is a beautiful language of which I have very little command, unfortunately. So I needed to put some effort into that. So yeah, why use Rust for audio applications in the first place, and for web audio applications in particular? So the memory aspect, memory safety aspect, I already lost a few words about that, why you would want to have that in audio software. Rust boasts itself with fearless concurrency. So for multi-threading applications, it might actually be pretty good. It's a deterministic systems programming language. It gives you stable results. You don't have any garbage collection to deal with, and don't have to expect glitches. You can port it to the web, or if you're not happy with the web audio software anymore, you could easily compile it to a native executable. The WebAssembly integration is very seamless, like compared to C++ or other languages, where you have to struggle with mscripten or whatever. For Rust, you just set a different target and there you go. And last but not least, the performance. I only did some very casual profiling in the developer console, but I had to, like, looking at the numbers, the main audio processing method needed roughly 15-20% less than the native JavaScript applications. I made an application to test sample playback and to work around, in general, get used to working in Rust and WebAssembly. This usually needs headphones, so it doesn't do a lot on a single mono speaker, but it's just a very simple sample player. And for profiling this stuff, I did the same thing in pure JavaScript, and it seems to be more reliable with Rust and WebAssembly. So, what are the ingredients of a web audio application made with Rust? Well, first of all, you need your DSP module that is compiled to a WebAssembly module. Like, BindGen doesn't really work that well in that context, so it's a raw library that you compile to WebAssembly. You need the audio worklet that holds the module. It's a part of the Web Audio API that allows you to do custom DSP processors, and that can use a WebAssembly module. You need some setup and control script, obviously the main thread, the user interaction. If you want to do any scheduling, any time-based stuff that's coming along, you need some additional web worker thread for sequencing and this kind of things. And ideally, some pure Rust DSP crates that easily compile to WebAssembly, as opposed to bindings, like if you want to use some advanced C Fourier transform libraries like FFTW or whatever. Well, it's probably harder, but with the pure Rust crates, that works pretty well. What are the challenges of making web audio application with Rust. The audio worklet and web worker stuff is a little bit tricky because you cannot load the modules directly. You have to fetch them in the main thread and then post them using the message system. But once you got through that, once you got the setup done, it's fairly easy. Setting up the shared memory between the WebAssembly and the main JavaScript is a little bit tricky. And yeah, as I already said, it was the bindgen for the worklet part itself for the DSP module doesn't work all that well because because of the limitations of the audio worklet, that you cannot load a module directly in the worklet, that you have to post it there in binary data. What's already there and of crates that support or that help you creating audio software with Rust. There's CHFFT, a pure Rust Fourier transforms library, if you would want to do any convolutions, any FFT-based effects. I used that for the binauralization of this part, like for the simulation of the 3D impression in this, if you want to check this out with headphones and play around with it a bit. The current version is still time-based convolution, but the new version that I might upload soon is based on actual fast convolutions. There's an alternative called RustFFT, but I haven't had a lot of success with that. There's some basic DSP crate, which I wasn't super happy with because it's a very vector-based way of thinking, and well, that's a little bit too detailed maybe. But anyway, it exists, so you might want to check it out if you are into DSP and want to do some audio software with Rust. What's not working all that well yet? I haven't managed to do any threading directly from Rust, so in the sense that I want to spawn a thread to do scheduling tasks, to schedule music events. So you still have to rely on the web workers, I think, unless somebody knows something more, and I'm willing to learn, because as I said, I'm still fairly new to that in the first place. Debugging is a bit tricky, as we already learned in the talk yesterday. It's you should test your DSP code well to make sure it runs, because to debug it directly in the WebAssembly part is fairly annoying. And unfortunately, the audio worklet is not yet available in Firefox. So so far it only works in Chrome and Opera, which is a bit sad, and I hope it will be implemented in a proper way in the future in Firefox as well. But we are not there yet. So what is to be done? Like, one of my future tasks in general is to do some general benchmarking, because I want to know how the Rust software on the web in particular, but also in general, compares to my C++ stuff, which I haven't done yet, especially regarding fast Fourier transforms, which is a central thing in my daily work. To do fast convolutions crate, to be able to do reverbs on the web and I don't know things, what other things. And in general, I'd hope maybe somebody will be inspired to do audio software and we can sharpen Rust profile as an audio language in general, so I can avoid in the future having random memory contents pumped into my ear directly, because as I already mentioned, that's not a very pleasant experience. So yeah. Some resources. There's a Rust audio forum on rustaudio.discourse.group. If you need any help or introductions into Rust Audio, the Rust Audio environment is actually bigger than you might think. I haven't mentioned some things like there's a VST crate that you can use to do plugins for digital audio workstations like Ableton and whatnot, which I haven't used so far, but I know it exists. So if you want to look for any resources, that's where you would go. This is for some examples, if you want to learn from that, especially with the WebAssembly part. There's this original seminal example that I already presented. It's all in Japanese. If you speak Japanese, there's a lot of stuff written about that. If not, I did the sample player I presented you right now. It's well commented, so it might be a nice starting point for your own applications if you want to check that. And last but not least, a more complex example that I made, and as you say in my native language, grau ist alle Theorie. I might give you a little demo of that to give you some impression what live coding means and what you can do with Rust and audio. So put the microphone away and give you a little impression of that. Thank you for listening. I don't know if there's time for questions or anything else. All of this is running in a web browser. It doesn't need any kind of server backend. You just need to load a web page, and there you go.
Hi. Amazing talk and demonstration. Thank you very much. Last time I checked for web audio in Firefox, I think there was a limitation of 256 milliseconds on latency. I don't know how it is now, but depending on which kind of applications, latency is very important. Do you know if this is changing, or? And also, which is the difference between our audio worklet and web audio? if there is a...
I would assume it's getting less and less. 250 milliseconds sounds quite a lot. I must admit, my own work is mostly based just on output, not on input. I don't do live processing where this would be very important. So, but I've seen applications that do guitar effects in a web page, and they're fast enough so that you can play it with the recent advances. Like this, I don't know if I could find it yet, but there's like guitar effects simulations that run on the browser with the WebAudio API that are at least fast enough to test them and not completely bring you out of the rhythm when you play guitar. So I assume that would be better now.
Hi, great talk, by the way.
Thank you.
In the RustFest playthrough, there was a sort of scripting language that you typed and it made the music.
Yes.
What is it? Do you want the parser for it?
No, that is just a very, very simple pattern parser. It's basically just a sequencer that I made to test it. It doesn't have big functionality. That's my next project, basically, to make an actual more complex language for the synthesizer to use it more productively, or to port, I don't know, my existing stuff to this kind of things, and maybe other stuff. There's a lot of nice live coding languages, so that's a future project.
Good luck.
Thank you.
Final question? Raise your hand.
I'm curious if it would be technically possible to do this kind of audio processing with the main web audio without audio worklet, and if you can explain why this needs audio worklet, maybe it would help motivate implementation in more browser.
Well, there's always multiple ways to do things, but yeah. One of the reasons for me is, for example, that if the performance isn't enough, I can use it natively as well and in different contexts, which might not be that great with pure JavaScript. Of course, everything of that could be done in pure JavaScript or with different tech stacks, but I think the WebAudio API itself and the nodes it currently provides is not that flexible. For example, all the timing stuff you saw here is done in the Rust part, like the precise time, the scheduler, the pattern language only gives out very coarse events, and they're like re-queued and re-ordered in the Rust part, and so on and so on. So I think the complexity might just be easier to handle if you have a systems programming language there instead of the basic WebAudio API facilities. But of course, I mean, that's all personal preference in part. So there's of course different ways to do it, and whatever suits your needs, you can use it.
Thank you, Niklas. Give him a warm applause.